today we're going to talk about forecasting in practice. Okay. So, I would like to start with an example. This is from the Chase book, okay? And it's about an oven cleaner. So this product, this SKU is an oven cleaner, and they have the, I think there should be monthly sales, 92, 93, 94. And if you look at the trend, there's a downward trend. There's some seasonality, and then there's a downward trend. So their forecast for the future is this product will keep declining. Okay, so this is their forecast for the future. And the question is, as a manager, what do you do? Okay, so an average manager might think, okay, this product is going to decrease over time, and at some point it will reach the break-even point. Okay, so below the break-even point, this product will not be profitable anymore. So when the product reaches the break-even point, you want to stop production. Okay, so that's a very, very common way of thinking about this. Okay, but is there a better way? Is there a better way? So this company, this is a real example, actually, by the way. So what they have done is, they have started thinking about this. So there's a downward trend. Okay, we understand that, it's very clear. But then they started asking, why is there a downward trend? Okay, why are people buying fewer oven cleaners? Do our competitors have a better product? Or is this going out of style? Is it an environmental concern? So they started thinking about why this product is going down. Okay, so as it turns out, people were starting to buy self-cleaning ovens. Okay, so if somebody has a self-cleaning oven, they're not going to need an oven cleaner. And as more people bought self-cleaning ovens, fewer people needed oven cleaners. Okay, so that was the case. So now they understand why there's a downward trend. And then the question becomes, can we do something about it? Can we reverse this? Okay, so this is a dying product. Okay, if we don't do anything, pretty soon this product is going to reach the break-even point, and we're going to stop production. Is there something we can do to change this trend? Okay, so they came up with the idea of repositioning the product. Okay, the thinking was, can we do something to convince people with self-cleaning ovens buy our product? And at first you might think, like if I have a self-cleaning oven, why would I buy oven cleaner, right? But the thinking was very good, and they said, well, self-cleaning ovens are great, but they generate a lot of heat in the kitchen, and it takes a long time, maybe 2 hours, for the oven to self-clean. So they proposed to position an oven cleaner as an interim solution between self-cleaning sessions. Okay, so between self-cleaning sessions, you could use an oven cleaner for a quick clean. Okay, so when they repositioned the product as is, this became a complement to a self-cleaning oven. Okay, previously the self-cleaning oven was a substitute, a replacement for this, but with the new way of repositioning the product, the oven cleaner became a complement that could be used with a self-cleaning oven. And when they repositioned the product, they changed the trend. This downward trend was stabilized. So they could stay in the market, they could keep producing the oven cleaner. So this brings me to a very fundamental question. What is the goal of forecasting? Okay. So obviously, one goal of forecasting is to produce the best prediction for the future. Okay? So that's certainly valid, but in my opinion, a more important goal of forecasting is how do you increase the revenues? Okay, so companies want to maximize their profits. One way to do is to increase their revenues. Another way is to decrease their costs. But increasing revenues is always more important than decreasing costs, for at least 3 reasons that I can think of. First, you can only lower costs by so much. But is there an upper limit to increasing revenues? Okay, so there's much more opportunity to increase revenues than to cutting costs. Okay, so that's one thing. The other reason is, as you sell more, revenues will increase, but at the same time, unit costs will decrease. Okay, just by selling more, your unit costs will go down because of economies of scale. And thirdly, the most important reason is, if you grow revenues of a company, that excuses all managerial mistakes. Sad but true. Okay? So then the idea becomes, when you generate forecasts, your managers are not interested in your MAPE, your managers are not interested in the techniques that you use, your managers are not interested in the details, okay? So your biggest contribution to your company will be to use forecasts to increase revenues, okay? So now, forecasting becomes a target setting exercise, okay? So the management wants to grow the business for the reasons I just listed, okay? And when they look at forecasts, they're thinking, okay, how can these forecasts help me increase revenues, okay? They always try to push their organizations to sell more and more and more, okay? So as a forecaster, what do you do? Because as a forecaster, you don't have a lot of authority to make decisions in the company, okay? How can you increase a company's sales as a forecaster? You can't, right? But the managers will push you. And if you just give them a forecast, and they're very likely to scratch your numbers and give you a larger forecast. Okay, that's basically target setting. So how do you approach a situation like this? So you can respond to the manager's desire to increase sales by taking the following steps. The first thing is, when you're forecasting, okay, when you're forecasting, you shouldn't just be concerned with numbers. You should also try to understand cause and effect relationships. Okay, so why are these products increasing? Why are the sales going down? Why is there fluctuation? Why is there bias? Okay, which regions perform better? You know, what are the competitors' products doing? Is there cannibalization? Okay, so when you understand what is going on, okay, when managers push you, you can respond to them by explaining what could be done. Okay, so if a manager says your forecasts are too low, increase your forecasts. Okay, when they tell you that, you can respond with, okay, we can increase the forecasts, sales, but we need to do X, Y, and Z, because given these cause and effect relationships, forecasts will currently not increase as much, okay? So under current situation, this is our forecast. If we want to increase the forecast, these are the things we need to do, okay? So the managers are basically looking for ways, they're looking for guidance from forecasters, okay? So they're not looking for a number, okay? They're looking for a way for suggestions from you as the forecaster of how to increase sales. So you need to understand what drives the sales, okay? And then another thing you should respond with is what if analysis, okay? So instead of generating a single forecast, you need to look at different scenarios, okay? So we're going to talk more about this later today. And you need to give them contingency plans, okay? So you have a forecast, you have a scenario, but you should have plan B, plan C, plan D in case things don't go as planned, okay? So as a forecaster, you shouldn't focus on just numbers. You need to understand what is going on. You need to consider various scenarios, and you need to have backup plans for your forecast. Okay. So we've been talking about demand forecasting, okay, and sales forecasting. Are they the same thing? Okay, so is demand forecasting the same as sales? Is demand the same as sales? Okay, now they are not. Why is demand not the same as sales? For one very obvious reasons. We observe sales, we record sales, we have records of sales, but we don't observe demand. We don't observe the actual purchase intentions of customers, okay? So how come they're not the same? How come we observe this and not that? So the thing is, we have constraints, right? So we can only produce so much, and sometimes demand exceeds production, and we can only sell so much. But there will be some more demand that's not satisfied, and that is unmet demand, okay? So observed versus latent. Latent means you don't observe demand. Now, there are customer purchase transactions, okay? and there are shipments, and there are customer orders. Okay? So, are they the same thing? Okay? So, do manufacturers ship as much product as customers want? Okay? Is the transaction volume exactly the same as the shipping volume, the shipment volume? Also, are the shipments from manufacturers to retailers the same as what retailers ordered from the manufacturer? So do the manufacturers ship exactly as much as retailers order from them? Okay, so we have the records for customers' orders. We have the records for the shipments from the manufacturers, and we have the point of sale transactions. Are they all the same? Okay. So, or can we move around the shipments? Can we move around the orders? Okay. What happens if customers substitute one product for another? Okay. So when that happens, the demand for the product which is out of stock will be underestimated. The demand for substitute will be overestimated. Okay? So in most cases, consumer demand is not the same as orders, which is not the same as shipments. Okay? So in most cases, we cannot completely observe true demand. Okay? So when you look at the numbers that you're forecasting, when you look at your time series, you need to know what you're looking at. Are you looking at point of sale data? Are you looking at shipment? Are you looking at orders? So you need to understand the data generating process, the process behind those numbers. Okay. So here's a graph of this. Okay. So there's a thin line and then there's a thicker line. Okay. So this thinner line is shipments. Okay. So there are larger shipments. Okay. So why are these spikes in shipments? Okay. A lot of times manufacturers push products onto retailers because they want to meet their sales quota for the week, for the month, for the quarter. So they just make regular shipments, and at the end of the quarter, at the end of the month, they ship a huge amount because they want to meet their quota. Okay? So if you have a spike at the end of the month or at the end of the quarter, there will be a lot of product at the retailer. Consequently, in the following weeks, the retailer will not order as much because they already have a lot of product. Okay, so they order less. Okay, so the thinner line shows you the shipments. Let's look at the consumption, how much consumers buy. If you look at this, the consumers buy at a very steady rate, okay? But the shipments show many spikes, okay? So now, as a forecaster, if you have both time series, should you forecast the shipments or should you forecast consumption? Okay, so So you have the data, and then you have two time series. Apparently, they both show demand, but they look very different from each other. So the question is, which one should you forecast and which one should you use to make decisions? Okay. So another consideration is demand exogenous and endogenous. These are, maybe I shouldn't have used these words, they're kind of fancy words. So what this means is that your demand, can you influence demand or not? Okay, so if so exogenous means made outside, endogenous means made inside. So if your demand is exogenous, that means your demand is controlled by outside factors beyond your control. So let's say you're selling insulin medication. That demand is, of course, exogenous. I mean, people will buy insulin as much as they need it for medical purposes. You can't really, you can't advertise and, have people buy more insulin. They need as much as they need, and that's it, and not more. But endogenous means there are some factors within your control where you can influence demand. Okay, so let's say Botox. Okay, the demand for Botox is endogenous. You can do something about it. So those are two different types of demand. And maybe sometimes demand is somewhere in between. So let's suppose you're selling eyeglass frames, okay? So part of the demand could be endogenous, part of it could be exogenous. So some people will need corrective lenses, and that depends on the population. And then some people will want to have cool sunglasses and frames, etc. So your demand could be partly endogenous and partly exogenous. And the distinction is, what do you do as a manager when your demand is exogenous versus endogenous? So you need to understand what part of sales comes from exogenous demand, what part comes from endogenous demand. Okay. So now, another issue we've talked a little bit about before is overfitting. Okay. Now, overfitting is so when you develop a forecasting model, sometimes the forecast quality looks very good, but it could be deceiving because when you over forecast, the quality of the forecast looks very good, but actually it's a bad forecast. Okay, so let me show you an example of this. Let's say you have data that shows you a U-shaped relationship, something like this. Okay. Now, if your model is too simple, it's not going to capture the curvature here. It's not going to capture the U shape. So if you use a simple model, which is a straight line, that's underfitting. Okay. On the other extreme, you could use an overly complex model that captures all the little nitty-gritty and gives you a misleading result. Okay. So you don't want to underfit and you don't want to overfit. So that's the idea. Now the question is then, is this a common problem? Is over forecasting a common problem you should worry about? And the answer is yes. Over forecasting is very, very easy. Why? Well, because we have a huge number of analytical methods that you can use for forecasting, and people keep developing new methods every day. So there are a lot of methods available, and they can be very, very complicated, very difficult to understand. Also, we have a lot of data, okay? So you need to be careful about your data, what kind of data you have, how good the data quality is, and we have a huge processing powers. It's very easy to run the models. It's very easy to run these complicated models. The data is there. You can run these models. The processing power, the computers are very fast, and all of this processing power comes at a cheap cost. Okay, so the idea then becomes it's very easy to be carried away by a lot of data, by a lot of methods, analytical methods. It's easy. You don't have to buy expensive hardware. So you need to be aware of the possibility of overfitting. Okay, so how do people fall in this trap? Okay, how do people fall in this trap of overfitting? Typically, people tend to overfit when they rely on a single metric. Okay, if you're only considering MAPE, or if you're only considering mean squared error, and you don't rely on any other metric, okay, it's very easy to over forecast. Also, when you only consider historical data, okay, when you don't think about market considerations, when you don't consider qualitative data, if you just rely on the numbers time series, it's very easy to overfit. Okay, so how can you avoid overfitting? First of all, a very good idea to avoid overfitting is to use a holdout sample and use a visual inspection. What is a holdout sample? Okay. So let's say you have data that goes from period 0 to period 100, okay? So you have data all the way up to here, okay? And you want to forecast what's gonna happen after period 100. Now, when you forecast, it is a good idea not to use all of your data, okay? The idea is, let's not use all of this data to forecast, okay? Let's leave out some data, and let's estimate the model, let's calibrate using some part of the data, and let's use this holdout sample for validation. Okay, so let me rephrase this whole thing. So somebody may be tempted to use the entire data to calculate the MAPE. Okay, now the idea here is, if you use the entire data set to calculate MAPE, that may not be a good indication of MAPE here. Let me, sorry. So we want a good forecast here. So this is our forecast. Okay. So this is the region we want to forecast these periods, okay? So, and we want a high MAPE, okay? We want a high MAPE, okay? So, if we use the entire data set and calculate the MAPE, okay, this MAPE and this MAPE will not be very similar. Okay? A better way is to calibrate or estimate. So this is the calibration. Calibrate or estimate the model. Okay. This is the hold down sample. Forecast this period and calculate MAPE. Okay. Now this MAPE and this MAPE will be very similar. Okay. So this So here's a question. Let's suppose you have this data series, you have a forecast, and you have achieved a certain forecast quality. Will your forecasts here have the same quality? Okay, so is your forecast going to be equally good here and in the future? The answer is no, okay? So the reason for this is when you forecast here, when you calibrate your model, when you calibrate, when you determine your best parameter values, you make certain assumptions, and when you make forecasts into the future, those assumptions may not hold. Something will change in the future. Okay, we don't know what's going to change exactly, but something will change. So as you keep your parameters constant for forecasting future demand, your forecast quality will suffer. Definitely. Okay. So that's the reason why when you have historical data, the fit will be good, but when you forecast for the future, the fit will not be as good. Okay, so that means you should not have the same high quality expectations for the future data for the historical data. Okay. So let's think about what to expect. What kind of forecast quality is normal in real world? Okay, what should MAPE be? What should mean squared error be? What should bias be? What are acceptable or normal ranges for forecast quality metrics? Okay. Okay, this is still recording. So one thing you could do is you can use the naive forecast as a benchmark. Okay, so let's say you have a fancy forecasting method that you use, and you want to know, is this fancy method really good? Okay, one thing you can do is you can generate naive forecasts and see if your method, how much better your method is compared to the naive forecast. Okay, so that's one way of doing this. Another thing is you can compare forecast accuracy between different departments in the same company, between different regions in the same company, between different products in the same company. So you can use internal benchmarks to assess the quality of your forecasts. Okay. Another thing you can do is you can use industry benchmarks. So different industries have different levels of MAPE, mean squared error, etc. You can look at your industry average and see if your company's forecasts are above average or below average, and you can evaluate your forecast quality like this. But you should always be careful about the fact that forecast accuracy, okay, cannot be compared across different contexts. So you don't want to compare apples and oranges. So for example, if you want to compare your forecast accuracy to something, you want to make sure that the products are similar enough, the consumers are similar enough, the competition is similar enough. So you should not compare, let's say, the marker forecasts with, I don't know, computer forecasts or something like that. You want to make sure that your forecasts are similar enough. Okay. So a lot of companies forecast in hierarchies. Okay. So let's say you can have total sales for the company. So that's going to be a single product, a single number for the total sales of the company. Okay, that's one forecast. However, your company can be operating in multiple countries. So you break down this total sales in two countries. This could be United States, this could be Canada. Okay, for example. So you have two countries, and then in each country you could have multiple channels. Okay. This could be the online e-commerce channel, and this could be brick and mortar channel through retailers. Okay, in each country. Okay, and then so on and so forth. You break down your forecast into different levels of hierarchy. Okay. So then the question becomes, okay, here's another example of this. Let's say, so this is a product hierarchy. Okay, so at the top they have the total sales forecast. Okay, now let's say we break down the total sales into muffins and cakes. Let's say your company makes two products, muffins and cakes. Okay. So I break down the total into muffins and cakes. Okay, so this is the forecast for muffins. However, I sell muffins to this chain, store chain, Stuff Mart. I sell muffins to this chain, Sid's Club. I sell muffins to Groceryland, okay, and Food King. Now each store chain has multiple locations, okay? So this is the total amount that I sell to this company, and each location sells this much, this much, this much, etc. Okay? And then you can tabulate them and have different kinds of graphs for forecasting hierarchies. Okay? So, if you look at the forecast hierarchy, how complicated can it get? Okay, can you have a simple hierarchy, or will you have a very complicated hierarchy? So let's think about how many products does a company have? Now, a typical company will have dozens and dozens, if not hundreds of SKUs, okay? And a company will have typically multiple locations, many time periods, and so the question then becomes how big or how complicated will your forecast hierarchy be? Typically, forecast hierarchies will be incredibly complicated. Okay? So I may have given you this example in class before, but I was doing a project for Wendy's, and they, on their menu, there are 300 items. Okay, 300 items. So a Wendy's store can sell you 300 items. So you need to have 300 forecasts for each store, right? And then they have 6,000 stores. So 300 times 6,000. And you need to generate a weekly forecast, 52 weeks. So 300 times 6,000 times 52 weeks, it's going to be extremely complicated. So what do you do? Okay. The question is, how do you manage this complexity? In other words, how can you not get lost in this complexity? Because there's so much complexity that it's very hard to make a decision based on these forecasts. So how can you manage the complexity so that these forecasts broken down in these hierarchies will give you meaningful help in decision making? Okay? So where should you generate your forecasts? Okay? So let's suppose you have a hierarchy like this. Should you generate a forecast at the top and break down the hierarchy like that? Or should you generate forecasts for each SKU and then aggregate the forecasts? Okay. So this has many trade-offs. It depends on the company. But the main point is you need to understand the trade-offs. Okay. So when you forecast, you need to think about what decisions will be made based on your forecast. Okay. So let's suppose you forecast at the highest level and break down the forecast into regions and divisions, etc. So the advantage of this is it's very easy to do so. Okay. And but a disadvantage is how accurately will you make these divisions? Okay. How accurately can you break down the total forecast into each individual SKU? You may do it accurately or not so accurately. Okay? The other thing is, these products will have different seasonalities. So when you forecast total demand and break it down to SKUs, the seasonality in total forecast will be reflected in each SKU, even though some of these SKUs will have a different seasonality than the total demand. Okay. Again, there are a lot of trade-offs in making this decision. Okay. So when you start with a bottom-up process, so you start with the SKUs, individual SKUs, and then you keep aggregating them, you lose information. How so? Let's suppose you have two SKUs that are that have different seasonalities. When one SKU increases, the other SKU decreases, and vice versa. When you add up the two SKU forecasts, the total forecast will be relatively flat. So you lose the seasonality information in SKUs. Okay? So when you do a top-down approach, you start with the total sales. So that means you impose the same seasonality on all of the products, and some companies do a middle out. Okay, so middle out means you generate the forecast somewhere in the middle of the hierarchy. You aggregate those forecasts to find total forecast, and then you break down these forecasts into SKU level forecasts. So there's no one right answer. Okay, you cannot say it's always better to start at the top. You can never say it's always better to start at the bottom. Okay, it depends on these trade-offs, and you need to look at your own data, at your own company, at your own decision-making process, and each of these have their advantages and disadvantages. Okay. So, one issue about the hierarchies, okay? So the hierarchies are very complicated, and that makes it difficult for forecasters to provide meaningful assistance to decision makers. So if the hierarchies were simpler, the forecasters could help decision makers more easily. But then, why do product hierarchies become more complicated? Now, there's a lot of reasons for that. The first one is segmentation. Marketers love to segment. Okay, customers, regions, all kinds of different things. Marketers love promotions, and every time you do a price promotion, you introduce an artificial noise into your signal. In other words, every time you do a price promotion, you inject an artificial spike in your time series. Okay, and there are different marketing channels, competition, etc. The other problem is companies love new products. Okay, they keep introducing new products all the time. Okay, why is that? Well, there's a very simple reason for this. New products are more profitable than old products, existing products. Okay, so what this leads to is it leads to product or SKU proliferation, which means that your product portfolio keeps on increasing. Okay, if you don't retire any products, your product portfolio will just keep increasing indefinitely. So what companies do periodically is to prune their SKU or product portfolios, which means that some of they review their products and they discontinue less well-performing SKUs. They'll try to reduce the size of their product portfolio from time to time. Okay. So what does this all mean for forecasting? Well, as you can imagine, new products, okay, are more difficult to forecast. Okay, so every time you introduce a new product, you introduce a new unknown to the equation. And it's not only the new product itself, the new product will also cannibalize some of the existing products. Okay, So it's not only one additional time series that's difficult to forecast, it's also the effects of the new product on all the other existing products. Okay. So I'm going to skip this part. Okay. I want to briefly talk about judgmental adjustments. So when companies generate forecasts, so they use, I don't know, exponential smoothing or whatever, they generate a statistical forecast, and many times companies will manually override the statistical forecast, and they'll try to fine-tune the forecast, okay? And this is a very widely applied practice, and I'm personally a big fan. However, there are a lot of haters, okay? So there are a lot of consultants who don't like this. Typically, these are software vendors that sell statistical forecasting software, and they want everybody to accept the results from the statistical forecasting package, okay? And they always come up with reasons why you should never touch your statistical forecasts, okay? And this is from one of their studies, okay? So they say an apparel manufacturer discovered that its executive approved forecasts were 25 less accurate than simply a moving average forecast. Okay, so what they mean to say is, when you let executives meddle with your forecasts, when you let your executives touch your forecast, you lose accuracy. That's what they say. Okay. And then here's another observation, is they say, a retailer found that the moving average did as well or better than manually adjusted forecasts 75% of time. And you may like, oh my God, you know. So what they're saying is, whenever you touch your forecast 75% of time, you're better off leaving it alone, because moving average will do just as well, or if not better. Here's another observation from the study. Okay, another manufacturer with a good statistical forecasting system in place found that when manual adjustments were made, they made the forecasts worse 60% of the time. Okay, so these look very, very bad for manual overrides or judgmental adjustments, but my counter argument is they're only giving you part of the picture. Okay, so let's say they say here, well, if you touch the forecast, the accuracy will decrease 60% of time. That sounds bad, but how much does it decrease by? Okay, so the forecast the accuracy will decrease 60% of time, but it may decrease a tiny, tiny amount. They don't tell you how much the accuracy decreases. Okay, and the accuracy will increase 40% of time, according to these numbers. Maybe the accuracy will increase less frequently, but more. Let's say 40% of time, 60% of time, the accuracy will go down by, let's say, 1%. 40% of time, the accuracy will increase maybe by 5%. So on average, you may be better off. Like most of the time, you're going to decrease accuracy, but a tiny amount. A small percentage of time, less frequently, you will increase accuracy, but every time you increase accuracy, it's going to be a huge positive increase. Okay, so this is just giving you a half truth. Okay, so